Weight of oranges from farm DQM. You don't write DQM, please. Okay. You write your own farm name. Okay. So, and in the real situation, there's no way you can find the mean and the standard deviation of the weight of oranges produced in a farm, correct? Hello, am I right? So that one we will talk about it next week. Am I right? But this one question will tell you. So the weight of oranges, so we put W. So you have to give the variable a name. So W, the question says W is normally distributed with a mean of 130 grams and a standard deviation of 15 grams. So if naturally occurrence thing like weight of oranges is usually normally distributed and the standard deviation always is a bit bigger. Do you know why? Why the standard deviation is a bit bigger compared to if I pack a bag of sugar, 1 kg sugar, correct? By a machine in a factory, correct? The standard deviation will be smaller. Why the standard deviation is smaller in that case and bigger in this case? Can you give me a reason? Yeah. So I will talk about why this one have a higher standard deviation, because there are many variables that affect the weight of an orange. Okay, like the weather, the trees, the type of fertilizer is being used, and so on and so forth. And also, like for example, okay, like for example, in when you talk about trees, I don't know about oranges, but I know about rambutan. Rambutan, correct? If you, the way after you get harvest already, correct? The way you prune the tree is very important. That will determine the next year harvest. The size of the rambutan and so on. You must know how to prune the trees. So pruning the trees is a very important factor when you talk about farming. Hello? My question is, why W bar 9 is normally distributed? You Safan. Safan, Safan, jawab. Because the question say that the population, the weight of oranges from this population is normally distributed. So according to central limit theorem, the sample mean weight distribution of a bag of 9 oranges will also be normally distributed. What terms of rule are Pacharitani? I told you already, when you talk about the shape of a sample mean distribution, correct? Or the sum of the sample, correct? Distribution, correct? There are 2 parts. Am I right? You have to say, according to central limit theorem, the population weight of oranges produced by this, for whatever is it, is normally distributed. Therefore, No need tons of rules of thumb already, this one. Can you please? If you say rules of thumb, this is 9 only. 9 is less than 30. So how can? You must know which part of the shape that you are supposed to talk about. Okay, this one I can use normal distribution because the population weight of oranges is also normally distributed. So I can use that. Ayo, this is the second time we do this question. No. Okay, so the rest I'm not going to do. So understand? Okay, let's go to question 13. Let's go to question 13. What is the population? Okay. Sarafina, what is the population here? Okay, so customer. So the population is customer at a railway station. Customer at a railway station only. Tickets booth, okay? So you have to be very careful. Okay, so now what the variable is time taken to serve a customer. All right. Hello? Yes, to serve a customer. Right? So we put it as T. Can I not? Okay. So according to the question, this T is normally distributed with the mean of 45 seconds and a standard deviation of 20 seconds. Okay. May I know why the standard deviation is so big? Who can give me a reason why the standard deviation for this one is so big? 20, no, mean only 40. Can you give me a reason why it has such a high standard deviation? What is your sample size? 11 or 12? It is 11 or 12? Why 12? 11 people in front of you only. Yes, because you have to buy also. If you didn't buy the ticket, then how to go for? Yeah, so 11 plus you. So it's 12. You see or not? So don't just look at the number, you have to look at the scenario. Okay, so the sample size is 12. Okay, so this is your N. So now, you want to talk about Sn or T S12, or you want to talk about T bar 12? Which one? Okay, S12, because that is the total time that you have. Can I use T12? T bar 12, sample mean. Okay, I want you to try to use both and get the answer. Give you 5 minutes. Okay, S12 is normally distributed, correct? Why? Because T is normally distributed. You have to know the reason. So S12 is normally distributed with the mean what is the mean for S12? 45 9. 45 times 12 and mean of the population. You divide the 45 seconds to? You change to minute. Okay, so up to you. So how about the standard deviation? Square root of 12 times 20. So all in second, right? So this is the formula, correct? So you have to remember the formula. Then, so probability of S12 less than 10 minutes. So 10 times 60 seconds. Yeah, you change it to second there. So this is normal CDF negative 10 to the power 99, 600. If you do, you can just put 10 times 60, okay? Your calculator can take it. And here is 45 times 12. Here is square root of 12 times 20. Done. All right? You get the answer. Okay? Okay, so how can I use this? T bar 12 is normally distributed. That means these 12 people is a sample, okay? So the sample mean is normally, the sample mean time taken to serve a customer is normally distributed because T is normally distributed. So keep telling yourself what is the right thing. Okay, so my T bar 12 is normally distributed with the mean equal to the population mean, correct? So which is 45. And the standard deviation equal to the population standard deviation divided by square root of 12. So now how am I going to use the 10 minutes then? 10 minutes is the total time taken by 12 people. So therefore, the mean time must be less than 10 times 60 divided by 12. Take the average, correct? So therefore, probability of T bar 12 must be less than 50 seconds, correct? You can do that. So also use the same, but use different distribution. So this question you can do in both ways. Do you get the same probability? Yes. So you have to be very careful. Are you talking about the total time? Are you talking about the total? Or are you talking about the average? So if for this question you use both method and show it to me, correct, I will give you the same. So in writing your folio that time, you also can do that. You also can bring in some, up to you. So when writing your folio, try to incorporate everything that we learned in chapter 9 into it. That's it. Try to talk as much as possible. You try to give people the two different scenarios, two different ways of solving a problem. You get me? Hello? Both also will give you the same result. Can or not? Okay. So we still got 3 more questions to go. Yep. So you want to do the 3 questions next tomorrow? Okay. So we will do the 3 questions tomorrow. Okay, so I expect you to do question 40, or I expect you to try it. I will not go so slowly. Everyone must try all 14, 15, and 16.